Today, in the ninth module of the image processing series, we learn about the applications of image processing. Following are the few of the applications we are going to study in detail. The first is applications of digital watermarking. What is digital watermarking? The process of embedding a piece of code in a digital image, video or audio file in order to provide copyright information. This is closely related to steganography, which deals with hiding information within images so that it can be understood only by the intended user. With the high demand of privacy security, digital watermarks can be used by the original owner to monitor and track how the materials are used. Digital watermarks are also very useful to viewers because they can provide links to the original owner and related information. Here are some of the examples of digital watermarks. Digital watermarks can be broadly classified into two types, visible and non-visible. But this is a visible type and this is a non-visible type, although this can be seen to naked eyes but only in certain directions. For example, under the light, certain conditions. And this is another image where you can see it from any point of view. The visible watermark is just a stamp or like a notice or a written note that contains information about the owner of the copyright. Here in the case, it is top 3 images. The invisible watermark is not visible to the human eye under normal conditions. For example, this image of Gandhiji is not seen under normal conditions. The image can be seen when we look from an angle or as exposed to light. A watermark is done by following a few steps. First is the watermark generation, second is the watermark embedding, and third is the watermark detection. For example, if you want to embed this Indian currency with the image of Gandhiji, what we do is first we take the image of Gandhiji. That is the first step. That is watermark generation. The second is the watermark embedding. That is, we embed the image into the currency note. The third step is the detection. This is done in the user side. The image is analyzed for watermark and if found, the information in the watermark is used to verify whether this is a valid copy or not. The next application of image processing we are going to learn about is biometric authentication. Any sci-fi movies you look into, the first thing they show is biometric authentication, whether it may be a thumbprint or your retina scanning or your face recognition. Biometric authentication forms a strong link between a person and his identity because biometric state cannot be easily shared, lost or duplicated. Hence, biometric recognition is intrinsically superior and more resistant to social engineering attacks. Example, phishing. Since biometric recognition requires a user to be present at the time of authentication, it can also deter users from making false repudiation claims. Moreover, only biometric can provide negative identification functionality where the goal is to establish whether a certain individual is indeed enrolled in a system, although the individual might deny it. Here are the following questions to which biometric gives reliable answer. Is he the person who claims to be? Who is this person and is this person someone on a watch list? For example, the biometrics of a criminal in a police watch list can be put down in a server, and this can be compared with any human being, any person's fingerprint, thus finding whether this person is a criminal or not. We routinely use body characteristics such as face, voice, etc. to recognize each other. Some of the biometric authentication we are going to talk about is face recognition. For a human being, if I see a photo, I would definitely recognize this as some person XYZ, or I can say this person I don't know. But for a computer, a face is nothing but just another data, just another picture. So how do you recognize or how do you differentiate a picture and a face or features? This is done by feature mapping. For example, the image is scanned and features such as the upper lid or lower lid and right upper lid, right lower lid, nose tip, lip, upper lip, chin, etc. are marked and kept in the database. And whenever a person's face is search for these features, and if it matches, it gives positive reaction. This is more convenient than utilization of passwords or PIN, but at the same time, this can be costly. The next one is a fingerprint scanner. This is a fingerprint scanner that most of us would have come across in life in some of the time. Like maybe during the Aadhaar card registration or during the purchase, if we purchase GeoSIM. And this is an example of a fingerprint, a human fingerprint. This is not going to change over time. A fingerprint scanner is very convenient and is socially being accepted and inexpensive. The next one we are going to see about is vehicle number plate recognition and detection. With increased number of accidents and other such incidents related to vehicles, automatic number plate recognition, that is ANPR, automatic number plate recognition, can be used to and be very helpful to reinforce law and order. This can be done with the help of present road monitoring televisions or specially designed cameras for the purpose. ANPR technology must take into account plate variations from place to place. License plate recognition involves capturing photographic videos or images of license plates, whereby they are processed by a series of algorithms that are able to provide an alphanumeric conversion of the captured license plate images into a text entry. Different countries, states, and cities and regions have different standard dimensions. The applications of ANPR include vehicle screening, checkpoint, homeland security, or custom and border control, cargo container, etc. For a human eye to read this is very simple, but for a camera to recognize what this is and note down the number is very difficult, because for a computer data, this is just a set of pixels. So what the system does is match it with a certain set of already inbuilt pixel and mark it with the corresponding input. The next one we are going to speak about is content-based image retrieval system. The content-based means that the search analyzes the content of the image rather than the metadata such as keywords, tags, or description associated with the image. To give a general explanation of example of CBIR, we can take into account Google 2-3 years ago. What Google does is, if I upload an image of a rat or any animal and I name it as a bird, and if anybody searches for a bird, the image of the animal is displayed to the user. Why? Because I have used the word bird to it. Google does not, Google did not scan through the images before, but now it uses content-based image retrieval. And what happens here is the image database, that is, whenever I upload an image, that image is stored in the database. The visual content and the description is done. The feature database are marked and it is stored. And whenever a user inputs a query, the query is formed, and the visual content description, that is, if I input an animal, the first thing that would be Google would automatically understand some of the features of animal and it would search for the same feature in the feature database. If there is a similarity, it gives that result rather than the name, which means even if I give it a name of bird, give the name of an animal to a bird, it won't return me a bird when I search for an animal. There are a wide range of applications of CBIR. Some of them include medical diagnosis, military, photograph archives, retail catalogs, nudity detection filters, space finding, etc. The next one is text compression. Unlike the other compression that can be lossless or lossy, text compression cannot be lossy because we cannot afford to miss any particular data in it. Each word and symbol that may seem unimportant to a compressor may be of utmost importance to the user. Thus, text compression is always lossless. Consider we had to, compress this image, this text into something using image processing. So what we do is we search for common patterns and give them a symbol. Like for example, D is represented underscore THE underscore is represented as a sun. TTER underscore is represented as an umbrella, and PI umbrella is represented as a snowman. So when I put this star, a star which means a snowman, and a symbol, a snowman and a symbol. So what a snowman is? Picture. The symbol means spatter. The snowman is again pitter, and the symbol which means spatter. So what it is about is, the compressed data would look something like this, and this would be of 31 characters. So here what we need to note is we need to send the key along with the compressed data, because unless decompression becomes very tough. So the number of keywords transmitted is 31 plus 25, that is the key is equals to 36, which is at almost 40% less than the original data. So how much is it compressed? 40% compressed. So this is all we had to learn about the applications of image processing in today's lecture. We have already learned a lot about the application of image processing. This is just a quick revision of all of them. So this chapter won't take anything more than 1 or 2 hours for complete revision or complete understanding. Follow the notes for more details and more more important notes. And that's it for today. Thank you for learning with Junk Minds.